So in chapter 13, we'll be talking about different ways that humans obtain and use energy and the various types of resources that are available as options and the pros and cons of these different resources. So your textbook starts with an example of a case study on how hydrofracking is used to produce oil and natural gas. So there are two different technologies that humans use to extract or remove oil and gas from a certain type of rock known as shale. Okay, remember, shale is one of those metamorphic rocks that we talked about in the previous chapter on geology. Humans can either use horizontal drilling. Okay, remember what horizontal means? It means up and down. So horizontal drilling involves drilling straight down into the ground to reach those rocks. And hydraulic fracturing, fracture means breaking, is also known as hydrofracking. Okay, that's when rocks are broken or cracked to release the gases, and a tube is used to collect the gases as they're being released from these layers of rock deep in the earth. So your textbook talks a lot about some of the issues with hydraulic fracking, the increase in numbers of earthquakes in certain areas, and the damage to water supplies nearby. There's that really shocking picture that you should look at about the person turning on their tap water because gas has been released into their well by fracking. She's able to light the gas that comes out from her faucet and it actually catches on fire. So that's a big safety issue for people that live in the area where fracking occurs. So we'll be talking about the benefits and the drawbacks of using each type of energy that we talk about. So we'll be talking in general about non-renewable resources versus renewable resources. And we'll be getting into the differences between some of the specific sources, such as coal and natural gas, and solar, wind, and hydroelectric. Okay, each energy source has benefits and drawbacks. So first we want to talk about the net energy yield. It's one of the ways we evaluate how easy or beneficial it would be to pick a certain resource for some of our energy. Okay, the net energy yield is the amount of energy obtained from a particular resource. So how much you get that you can use in your house or in your car or to run some other facility, minus the amount of energy that's needed to produce it. So in the geology chapter, we focused a lot on coal mining, especially in the lab where you watched the Last Mountain movie. Think about the energy used to produce coal. All of the vehicles that are driven in order to collect the coal, all the people that need to travel to and from work every day, and the equipment that needs to be operated to extract the coal from the ground, as well as all the equipment that's needed to process the ore, remove the overburden, and take the coal out. Those are all sources of energy needed to produce it. So the net energy yield is going to vary greatly depending upon the source of energy. And it's not always consistent depending upon where that resource is harvested. Think about what we learned about ore in the last chapter. There are high quality ores where the rock contains a lot of a certain mineral, and there are low quality ores where a very small amount of that mineral is present, and more material has to be removed to get the same amount of that desired mineral. So let's say that we're removing gold from a high quality ore, And we run out of that, and then we've got to go to lower quality ores next. Some sort of mineral like uranium for nuclear power. And we start out by mining the high quality ore where there's a lot of it present in a certain type of rock. And then we run out of the high quality ore and we move on to lower quality ore. When we move on to that lower quality ore, we're going to decrease the net energy yield because we have to put more energy into collecting and processing the ore to get the same amount of that particular mineral. So keep in mind that when we classify the net energy yield for different sources, like coal, that's going to be approximate. Okay, it is going to differ depending upon where you're doing the mining. Okay, so keeping in mind that net energy yield can change slightly depending upon the conditions. So even though net energy yield can vary, and sometimes our models or decisions need to be changed depending upon finding new deposits of certain resources, or the fact that certain high quality ores are declining, the model may need to be changed from time to time, but net energy is still a very good measure for determining the usefulness of a particular energy source, both in the short term and the long term. If the net energy yield is 0 or negative, that's really not a good sign. Okay, we want a high positive number. A lot more energy is coming out than we can use than goes in that we need to collect or process that resource or turn it into the type of energy that we can use in our homes and cars. So a net energy of 0 or negative means that the resource is not going to be viable in the marketplace. No one wants to spend more money than they get. Okay, there are a few resources that we do use with 0 or negative numbers for the net energy yield. And for those, the government has to help subsidize them. For some reason, they might decide it's a good clean alternative to using other sources of energy, and they want to support that. So essentially, they're lowering the cost to the public by putting in government subsidies. For whatever reason, they may want to use that resource. Maybe it's cleaner and less environmentally destructive than another resource. So we have talked a lot about renewable and non-renewable energy sources already, but we're going to emphasize this again because it's one of the most important concepts that you should take away from this course. Okay, remember that non-renewable energy sources are sources that we're going to run out of. There are fixed amounts or a determined amount of that resource in the environment, and they tend to take millions of years to form. Okay, once we run out of those resources, we're not going to be able to find more because we're using them on a much faster scale than the millions of years. Renewable energy resources are constantly being replenished or replaced by natural processes on a time frame that facilitates our use of them. Okay, like sunlight energy. We do have a fixed amount of sunlight hitting a solar panel at any one point in time, but when we use that energy, there's going to be more and more of it available. It's not going to decrease just because we used it. Okay, using the solar energy available today isn't going to affect the amount available tomorrow because the sun keeps supplying more and more and more. Okay, that's also the case with wind power and hydroelectric. So commercial energy is a total amount of energy that's produced from all of the renewable and non-renewable resources, and it's sold in the marketplace. So when you're turning on the lights in your home, you're using commercial energy. The power company is going to sell you energy at a rate of gigawatt hours based on the amount that you use. Some of that energy may come from non-renewable energy sources, such as coal, and others may come from renewable resources, maybe hydroelectric or wind power, depending upon the area in which you use and which power company you're using. This diagram here is in your book. I don't expect you to memorize all of it, but it does compare the net energy yield of various energy sources. Now, this is not the only thing used to determine whether it's good to use a particular energy source. Okay? This doesn't take into account the environmental impact of burning that energy or harvesting it. Okay? So this is only one of the things that we're going to consider when we make decisions about what types of energy to use.